Welcome to Module 001. Before we get into commands, terminals, or anything that looks like code, we need to build a foundation. And that foundation starts with a question most people never stop to ask. What is a computer actually made of? What's happening inside that machine when you turn it on? And what is the operating system actually doing while you're clicking around? Here's my promise to you for this module. By the end of this module, you'll be able to define what a computer actually is. You name its main hardware components and explain CPU, RAM, and storage in plain language, no jargon or textbook definitions. You will also be able to describe what an operating system does. You explain what Linux is and answer the question everyone eventually asks. Why does Linux dominate the cloud? Why is it powering AWS, Google Cloud, and Azure? Why not Windows? And we'll cover one more thing that most beginners skip: device naming in Linux. How Linux identifies and names your disk and storage. It's a small topic, but it shows up on the LPI exam. And more importantly, it shows up in real work. Now, one small thing before we move forward. Take a screenshot of this slide right now. Save it somewhere you can find. At the end of this module, we are coming back to this list, and you are going to grade yourself honestly against every single objective on it. That's how you know the model has landed. All right, let's begin. The most fundamental question of all: what is a computer? You use them every day, but have you ever paused to ask what they really are? That's where we start. A computer, by definition, is an electronic device that stores, processes, and retrieves information. It has two halves: the hardware, which is the physical part you can touch, and the software, the programs that run on top of the hardware. Think of a mobile money kiosk. The phone, the SIM, and the receipt printer, that's hardware. MoMo, M-Pesa, or Wave running on the phone, that's software. Without the app, the kiosk is just a table with a phone. Can you name 3 computers you use today that aren't a phone or a laptop? Maybe the traffic light controller, the smart TV at home, or the dashboard in a motorbike taxi. Computers are everywhere. Now let's open one and look inside. Inside every computer, 2 components do most of the heavy lifting: the CPU and the RAM. The CPU is the central processing unit, and it is the brain of the computer. Every calculation and every decision, as well as instruction, is carried by the CPU. Speed is measured in gigahertz. Picture a mobile money agent at a busy stand-say in Kimoronko or Bamenda market. Every customer who walks up, they personally count the cash, type the code, send the SMS. A faster agent saves more customers per hour. The CPU is that agent. RAM, random access memory, is short-term memory. Whatever the computer is working on right now lives there. The catch: RAM is volatile. If power goes off, everything in RAM disappears. Picture the agent's table, the current transactions spread out, papers and cash easy to grab. When the batch is done, the table is cleared. More RAM means more papers fit at once. Have you ever been at a cyber cafe in Bamenda or Lagos where you open too many browser tabs and the machine just froze? That's RAM filling up. The agent's table ran out of space. When you rent an AWS server, you literally pick how much CPU and RAM you want. A T3 medium instance, for example, has 2 virtual CPUs and 4 gigabytes of RAM. You choose the sizing of your agent and the size of their table when you are picking a particular instance. Time for our very first live demo. Let me ask a real Linux server how much CPU and RAM it has. To do this, we need to log on to our instance. This is the time that you have to fire your putty And if you did save your instance, you double click on it. Mine has here Ubuntu Linux. I'm going to double click on it and the logon screen is going to come on. And as you already know, the username to log on is Ubuntu. And once I hit enter, it's going to display a bunch of information that I'm going to ignore for now. We'll learn about it later. But I'll use the command clear. If I type under clear and hit enter, it gives me a clean environment to work on. Now, let me type my command. This ls, which is like list CPU, list the different CPUs. But I'm going to do something else. I'm going to do what is called pipe, and I want it to show the first 10 lines. We are going to learn more about commands, so please do not panic or be frightened at the moment, but just know that this is a command that will show me the CPU of my current system. Once I hit enter, I'm going to give you an interpretation of the key lines. The first one is architecture. x86_64. This means this server speaks the most common language of modern computers. It is the same thing like you have phones. Some use Android and others use iOS. CPUs have architectures. x86-64 is the standard for servers and laptops worldwide. Next, CPU or CPUs. 2. Your server has 2 virtual CPUs. So this is saying that this server that I'm running currently has 2 virtual CPUs. Think of these like 2 cashiers at an MTN MoMo kiosk. The more cashiers, the more customers save at the same time. The model name, Intel Xeon Platinum, with a CPU running at 2.50 GHz. This means the CPU can perform 2.5 billion operations per second. AWS normally rents you a slice of this powerful chip. Now, let's move on to the next command for the demo. -h. And if I hit enter, this is showing me the RAM on my Ubuntu server. This shows a total of 908 megabytes. This is the size of your store table. The amount used, 320 megabytes. You may be wondering, what is this being used for? The Linux kernel, the SSH session I've made. There are some background processes. All of them together are using 320 megabytes. 360 megabytes is free, which is good news because this is a learning server. Swap shows 0 bytes altogether. Swap is actually like emergency overflow space. When real RAM fills up completely, Linux can spill overflow onto the hard disk temporarily. Think of it like a vendor borrowing a neighbor's table when theirs is full. It works, but it's much slower. On this EC2 instance, swap is not configured at all, which is common for small cloud instances. Free RAM is not wasted RAM. Linux deliberately always keep unused RAM free so it can load new programs instantly. So a server showing 360 megabytes of free RAM does not mean it is wasted RAM. So when you are thinking of the commands lscpu and free-h, these are commands that are common to almost Linux admin in Africa and beyond. Computers need to talk to the outside world. That's input and output devices. Input devices normally send information to the computer. The keyboard, the mouse, touchscreen, microphone, webcam, those are examples of input devices. Output devices sends information back. The monitor, speakers, and printer are examples of output devices. The cleanest analogy, mobile money again. When an agent dials USSD code, typing the amount, entering the PIN, that's input. Instructions to the system. The confirmation SMS that arrives a moment later, that's output. The system answering the agent. The same conversation, 2 directions. Can you write down on paper 1 input device and 1 output device that aren't on this slide? a vibrator motor, a card reader at a POS, a buzzer at a security gate. Now, where does the data live when the power goes off? Storage holds your data permanently, even when the power is off. There are two main kinds: SSD, solid state drive, flash memory, no moving parts, very fast and shock resistant. You have HDD, hard disk drive, spinning magnetic disk, slower, more fragile, but cheaper per gigabyte. SSD for your operating system and apps you use daily. You want them to launch faster. HDD is for your backups, photos, videos, and large amounts of data you don't open every minute. The way to remember the whole hierarchy: RAM is the cache in your hand right now. Fastest access, but if you drop it, gone. SSD is mobile money, instant, digital transfer, always there. HDD, on the other hand, is the bank branch. Slower, you have to go there, but holds huge amounts. One more thing: a dying HDD makes a clicking sound, like a taxi engine that's about to stop. SSDs die silently. That's why we must always back up. You may not get a warning. Let's ask Linux whether the disk under us right now is an SSD or an HDD. So we have to go back and run a command on our Linux server. So I'm going to type clear. So the command I know I'm going to use is that /sys/block /nvme0n1 /pure/rotational. The NVMe0N1 is actually the kind of block device I have. We are going to learn about that shortly. But when you hit enter, it gives me 0. The output is 0. 0 indicates that it is an SSD. If this gives me a 1, it will have meant an HDD. So this server is running on an SSD. That's why it boots in seconds. Now, the next command that we are going to look into is hdparm -t, and I'm going to run this command on my block device NVMe0N1. I'm going to hit enter, and normally it's going to give me the actual read speed of the SSD. A typical EC2 GP3 SSD will always run about 400 megabits per second. So if I'm looking at the output we have had here, 502 megabits was read in 3.0 seconds, which is 166.59 megabits per second. An old HDD may be giving me about 80 megabits per second, which is 2 times slower. That gap is the difference between a website that loads instantly and one your visitors abandon. Now, eyes on me. The next thing I'll tell you will be on the LPI exam. Now, Linux names storage devices in a very specific way. Windows uses C drive, D drive. Linux, on the other hand, uses /dev/SDA for the first disk, /dev/SDB for the second, /dev/SDC for the third. Partitions get numbers: /dev/SDA1 and /dev/SDA2. If you are thinking of the market analogy, /dev/SDA is the market row A. /dev/SDA1 is store A1. /dev/SDA2 is store A2. And /dev/SDB is actually the next row. So each disk is a row and each partition is a store. Keep this in mind for the LPI exam, and you will use it every day on a real Linux server. Now, if we look at this slide, which is listing the block devices, lsblk, the most important demo for this model, I will say, /dev/SDA is live. Read with me. Row A, SDA, 30 gigabytes, the whole disk. Inside it, you have SDA1 mounted at root. That's where the operating system lives. Row B, SDB, 100 gigabytes, mounted at /data. The market we drew on the slide, but this time real. Now, if you run the command ls/dev/sd*, there are actual files representing each disk and partition. In Linux, even hardware is a file. Remember that phrase. In Linux, everything is a file. We'll come back to it again and again. I want us to run this on our own Ubuntu server. So now this time around, I'm going to bring up the server. I'm going to clear the screen. And what I'm going to do is I'm going to type lsblk and I'm going to hit enter. Immediately it comes up. You are going to notice a bunch of lines starting with loop, loop 0, loop 1, loop 2, and so on. Don't worry about those at the moment. Think of them as temporary pop-up styles in the market. They belong to what is called snap packages, which are self-contained application bundles. They are mounted, they work, but they are not your main storage. We're going to ignore them for now. The important line is the one with NVMe0N1. This is row NVMe0, your main disk. It's an 8 gigabit EBS volume attached to this EC2 instance. On a traditional server, this will be called SDA, row A. But on AWS, because they use faster NVMe solid-state drives, it is called NVMe0N1. Different name on the sign above the row, same concept. Now look at what's underneath it. Those indented lines, those are the stores inside row NVMe0, the partitions. NVMe0N1P1, that is store NVMe01, is the biggest one at 6.9 gigabits. This is where Ubuntu lives. When you log in, run commands, create files, you are working inside the store. It's mounted at /, the root of the entire file system. Everything starts here. NVMe0N1P13 is for store NVMe0-13, 1 gigabit, mounted at / boot. This is where the Linux kernel and boot files live. When you power on the server, this is the first store Linux opens to get started. NVMe0N1P114, that store NVMe014. It's just 4 megabytes, no mount point. Think of this as a structural wall in the market. It's there for a reason, but no vendor sells from it. It's the BIOS boot partition. NVMe0N1P115, store NVMe0-15. It's 106 megabytes, mounted at /boot/EFI. This is the EFI partition. It's the entry gate to the market. Modern systems use it to hand control over the operating system during startup. So to bring it all together, one disk, one row, 4 stores, each with a specific job. Linux doesn't just dump everything in one place. It organizes storage intentionally, just like a well-run market. And on AWS, that entire row, the NVMe0N1 disk, is actually an EBS volume. It's not a physical drive sitting inside a computer near you. It's a virtual storage provisioned in AWS data centers and attached to your EC2 instance over a high-speed network. That's the power of cloud infrastructure, which we'll come to very soon. Moving on. Types of computers. We know what's inside one computer. Let's see the different shapes computers come in. Computers come in several shapes, sized for different jobs. A personal computer, desktop or laptop, is for productivity, browsing, and entertainment. A workstation is for heavy work, 3D design, video editing, scientific simulation. A server handles many requests from many clients over a network. So you think of websites, email, database, and cloud services. Mainframes aren't extinct. The core banking system at EcoBank, Equity Bank, or Standard Bank, the thing that knows your account balance, is almost certainly on a mainframe in a secure data center. When you swipe your card at ShopRite, your transaction touches a mainframe within milliseconds. Embedded computers like inside cars, smart TVs, ATMs, your motorbike's dashboard. In this entire course, we are going to focus on Linux servers. Why? The same Linux server powers AWS, Azure, Google Cloud, and African tech giants like Flutterwave, Paystack, and MTN. Quick scenario, you are starting a small SaaS for a university hostel in Kigali. Which type of computer do you rent first? A server. That's where every cloud business starts. Let's zoom into the one type that matters most for this course, the server. Look at the diagram. On the left, 3 clients, a phone in Lagos, a laptop in Accra, or a phone in Kigali. On the right, one Linux box sitting in an Amazon data center. Between them, arrows. HTTP request travel left to right. Response travel right to left. Many clients, one server. That is the shape of every web application, every API, and every cloud service in existence. Why does this matter? Because when you SSH into an EC2 instance, in the next model, you are the client on the left. And you have been doing that if you have logged onto your server. The server is the Linux box on the right. The arrow between you is an SSH connection, the same shape as any other client-server pair, just a different protocol. Now, here's a real example. Flutterwave is processing payments across Nigeria, Ghana, Kenya, and Rwanda at this very moment. Millions of phones are the clients. A fleet of Linux servers in data centers are on the right. The arrows are HTTPS requests, carrying card numbers and amounts. Linux handles every single one of those arrows. That is why we are here. Quick question before we move forward. What's the difference between a server and a personal computer? Same hardware, but different purpose. A server is designed to serve many clients simultaneously. It runs headlessly, with no screen, no keyboard, access only over the network. That is exactly what an AWS EC2 instance is. Okay, time for a quick recap. But we are doing this actively, not passively. I want you to cover the slide with your hand and don't pick. I say a word and you say the role out loud. Ready? CPU, the brain of the machine. RAM, short-term volatile memory, gone when power cuts. SSD, fast permanent storage. HDD, cheap, large, slower storage. Motherboard, the board that connects everything together. /dev/SDA, the first disk in Linux. Now, uncover the slide and check yourself. You have earned the next section. If you miss one, write it down. That's your weak spot, and the lab will test exactly that. We have talked about hardware. Now let's meet the software that brings it all to life, the operating system, and specifically Linux. An operating system, OS for short, is system software that manages your hardware and your other software. It decides which app gets the CPU right now, where files live on the disk, who is allowed to access what. Without an OS, your hardware is useless metal. Picture a bus station dispatcher, say at Kimoronko Market, or in a city beside you, Buses constantly arriving and leaving. The dispatcher decides which lane, calls departures, manages the schedule, gets passengers safely to destination. Now imagine that same station with no dispatcher. Buses arrive in random lanes. Drivers shout over each other. Passengers board the wrong bus. That's a computer without an operating system. Every program fighting for the CPU and the disk. The OS imposes order. The big names that you know already. Windows is on most desktops. Mac OS on Apple. Linux on servers and the cloud. Android on phones, which is itself built on Linux. iOS on iPhones. You have already been using operating system all day long. So what is Linux? Linux is free, open source operating system kernel created by Linus Torvalds in 1991 as a student project. Open source means anyone can read, change, and share the code. That's why Linux is everywhere now. Costs nothing, runs almost anywhere, improved daily by a global community. And the community isn't just in California or Helsinki. Kernel contributions in Cairo, Cape Town, Lagos, and Nairobi. After this course, the door is open for you to contribute too. Linux doesn't ask where you come from, only if your patch works. Quick stats. Over 90% of cloud servers run Linux. The top 500 supercomputers, every single one of them runs on Linux. 3 billion Android phones run in Linux. Most smart TVs, routers, and cars are running using Linux. If you work in cloud or DevOps, you will spend your career talking to Linux machines. I want you to pause for a second and think about this question. Whose phone right now is running Linux? Take a moment, think about it. If your answer was not mine, that's actually a trick question. If you are holding an Android phone right now, you are already running a Linux kernel. You have been running Linux for years. You just didn't know it had a name. I'm going to show you a screenshot of how it looks like on my own phone. Now, if you go to your Android phone and you click and you go to settings and pick the section of about your phone, you'll be able to read the kernel version. In some phone, you may need to go to detail info and specs. This happened on my phone. So this is the kernel version. It's stated right here. Another way to check if your Android phone is running Linux is to install a small app from Play Store or Termux. If you install that app, and then if you run it, and then if you go and type uname -a, it's going to give you something like this. Linux localhost 6.6.7. You see, this corresponds to the kernel version that I have here. So what am I actually showing you? That this is not a server in a data center somewhere. This is your personal device, and it has been running Linux the whole time. So when people say Linux is complicated or only for experts, remember this moment. We have been living with Linux before this course even started. Today we are just making it official. Linux is really two layers working together, and this distinction will help you for the rest of your career. The kernel is the core. It talks directly to hardware. It manages memory and schedule processes. It also controls drivers. It runs in kernel space. This is the protected zone. User space is where everything else lives. Your shell, the text editor, browser, and every other application. They never talk to hardware directly. They ask the kernel politely through system calls. Why the separation? Safety. If your browser, for example, crashes, it cannot take the whole machine down. The kernel will keep running. You just have to relaunch. When your laptop suddenly freezes with white text on a black screen, that's a kernel panic. It is like the operating theater at an emergency. Everything stops. We reboot. Compare that to Chrome crashing. Patient in Ward 3 is fine. Surgery continues. That's the value of the separation. So in the hospital analogy, Kernel space is the operating theater. It is sterile, restricted. Only authorized staff can get in. User space on the other end, the wards and waiting room. Patients and visitors interact freely. For surgery, they go through proper channels. The separation is why Linux servers run for years without rebooting. Now, let's do the last demo for this model. Kernel and user space side by side on a real machine. So I'm going to go back on the Ubuntu machine. I'm going to type clear. Again, the command here just gives me a clean working space. I'm going to type the command uname -r. What does this give me? It's going to tell me the kernel version. So uname -r, I hit enter. It tells me the kernel version is 7.0.0. Now let me run the command ps -ef, and I'm going to type that to head. I want to see just the first 10 lines, for example, right? So every line in this output is user space process. If you look at it carefully, the kernel is not in this list. Why? Because it is the stage they are all standing on. All user space processes are actually depending on the kernel, so you won't see it on this list. To have a look what system call is, we need to run another command. The command we're going to use here is trace -e open at ls/2 and I'm going to get just the first 5 lines. We are going to get used to these commands, so don't panic at the moment. So when I hit enter, I made a mistake, which is normal. You are going to experience that. I'm not going to remove this. I actually wanted to type trace, right? So it should be there should be an trace. What's happening? There should be an R here. And if I hit enter, you'll notice that each line starts with open at, right? This is a user space program asking the kernel, please open this file for me. The conversation across the boundary in real time. All right, back to our PowerPoint. Before we close, a tiny preview of what is coming. In the next model, you will log into your Linux server and see this prompt. You will type your first commands, you will navigate the file system, and you start to feel at home in the terminal. So come prepared. Let's learn everything. Remember the hands you raised at the start. Every one of those MoMo transactions touched a Linux server. Now you know what was inside that server, what an OS is, and why it had to be Linux. You have moved from a user to insider in less than 90 minutes. That's real progress. Computer is hardware plus software. Hardware has a brain, CPU, short-term memory, RAM, and permanent storage, SSD or HDD. The OS is the dispatcher. Linux is a free open source OS that runs the cloud, the supercomputers, and most of the internet. Split into kernel space, a protected core, and user space, where your apps live. From the next model onward, we'll leave theory and start touching real command line. That brings us to the end of model 001. Before you move on, go ahead and complete all the remaining modules activities. Walk through the hands-on labs, answer the knowledge check questions, and attempt the certification style questions. Take your time with those. They are there to make sure the concepts have landed, not just been heard. Once you are done and confident, then move to model 002. In model 002, we are going to meet the command line for the first time. Bring a curious mind and a notebook. As always, let's rule the clouds. See you in the next model.